So guys, what is angle of friction? It is the angle between the normal reaction and the resultant reaction force between the normal reaction and the friction. So basically we know this particular thing is, see, suppose if there is any block over here which is placed on the ground, and you are applying some external force due to which certain friction is being developed in this. So let's say this is F, if this is F and this is the normal reaction. So if I want, I can give the resultant of these two forces. So when I give the resultant of these two forces, will it look like this? Yes or no? Will this be the resultant of normal reaction and friction? Yes or no, guys? So basically, this angle is called as the angle of friction. Can you see it is the angle between the normal reaction and the resultant of friction and normal reaction? Is this clear? Is this clear, guys?
Yes, sir.
Yes, sir.
It's just a definition, nothing else. Sir, how will we calculate this thing? How will we calculate this thing? See here, can you see a triangle getting formed? If a triangle is getting formed, this is N, this is R, and this is F, right? Yes or no? And this angle was phi. So can you see from here tan phi is basically F upon N. So tan of phi is equals to F upon N. And friction is basically what? I think there is one small condition to it. It's like it's that condition when it is just about to slide. I think this is the condition when the block is just about to slide. I think this is the condition, right? Is this clear, guys? Is this clear, guys? Hello? Hello?
Yes, sir.
Okay. So tan phi is basically F upon N. And I think this angle of friction is defined when it is just about to slide. When it is just about to slide, then the angle between the normal reaction and the reaction force is basically called as what? The angle of friction.
Hello,
And
sir.
हाँ बोलो.
Hi, sir.
Hello.
So
So
वो
from
क्लास
here,
क्या
क्या हुआ? वो
क्लास
रीजन पर्सनल था भाई, नहीं बता सकता मैं, थोड़ा वो बाद में बता दूंगा. Whenever I feel
अच्छा
appropriate मैं बता दूंगा.
yes
टेंशन मत लो.
sir.
So this friction should be the limiting friction, right? If it is just about to slide, then friction should be limiting friction. So FL is equals to what? Mu s into n, and से n कट जाएगा, and from here phi is nothing but tan inverse of. Please write it down. Done.
So can you scroll up once? Just for 1 second.
2 seconds ले तू. तेरे
Done,
लिए
sir.
extra 1 more second, okay?
Yeah, done, sir.
Just tell me, guys, whenever you're done, just tell me. Done. Yes, guys, are you done?
Yes, sir. Yes, sir.
So this is basically your angle of friction. Now there is another angle. What is the significance? We'll talk a little bit later. Can you see over here? The angle of friction is basically tan inverse of the static friction. Okay. So note, till the time the angle between the friction, I'm not talking about limiting friction, okay? Friction and normal reaction becomes equal to the angle of friction, the object or the block remains at rest. So this is the physical significance. See, you can define this angle at any particular instant, but every time that angle will not be equal to what the angle of friction, right? You can define the angle, define this angle for any particular angle, right? What am I saying? You can define this angle between the total reaction force and the normal reaction when the object is at rest. At any particular instant, you can define it, right? But this angle will be maximum only when this friction will be equals to what? The limiting friction. So when it is just about to slide, then that angle between the normal reaction and the total reaction force is defined as the angle of friction. Okay, is this clear? तो जब तक वो वाला angle of friction के बराबर नहीं बनेगा, till that time the object will be at rest. Is it fine? Till the time the angle between the friction and the normal reaction, angle between the total reaction force and the normal reaction becomes equal to the angle of friction, object remains at rest. Is it clear? Is it clear, guys? Hello.
Yes, sir.
Please unmute,
Yes,
guys. Everyone
sir, I'm
unmute.
unmuted, sir.
Yeah, I know. Aman, Parinita, Sania, Cyril, please unmute.
Of course.
Tanish, what happened? Why did you unmute now? Aman as well, please unmute it. Aman and Tanish, please unmute it. I will not say it again.
Sir, my mom came.
Achha. So
So,
after
yeah,
some time, please unmute it.
Sir, stretched on the camera.
Nah, after some time, unmute it.
Sir, ouch. Sir, I'm hurt. Okay.
Anyways, so is this clear? Till the time the angle between the total reaction force and normal reaction becomes equal to the angle of friction, the object remains at rest. Now the second angle which we want to discuss is basically called as the angle of repose. This is also the same thing only, but a little bit different definition. Can you see over here? Suppose guys, there is a plank. Can you see a plank?
Yes, sir.
And this plank can rotate about, let's say, this particular axis in anti-clockwise fashion. Let's say I have a block of mass m which is placed over here. Now what will happen when this plank starts going up? When this plank starts going up, does it make the diagram look like this? Does it make the diagram look like this? Yes or no? If this thing is rotating about this particular thing, and you see the plank had a block of mass m, and the plank was, let's say we rotated, we raised it by a certain angle theta. Okay, so can you see where it raised it by a certain angle theta? If we keep on raising this by a certain angle, then there will be one angle where this block will just start sliding over this surface. Yes or no? Yes or no? This is much good to explain when you see the practical in the class itself. The practical, we have that folding chairs. Okay, so basically we'll place a compass box or any object over there, and we'll start raising that particular thing. Have you seen has anyone come to the center? Guys, hello. You all came to the center, right? When in PTM, right?
Yes, sir.
So
Yes,
you
sir.
have
Yes,
seen
sir.
those chairs, with you have the flaps. You said you close it, right?
Yes, sir.
Yeah.
Yes,
So
sir.
basically, it's like the same thing. Suppose I place something over there, and I start raising the other end, which can go up, right? So when I start raising at one
Sorry, what?
particular, एक second,
Meeting, sir.
waiting, okay. Holding chairs for school images. Yes. 2 minutes. New share, holding chairs. Share. Do you remember the chairs in the office are looking, are like this? Everyone knows these
Yes.
types of, so these chairs I'm talking. You remember these flaps can go like this. The where
Oh,
you
that flap.
the notebook, these flaps can go like this, right? They can rotate about this
Yes.
axis. Everyone knows this. Right? Now,
Yes.
the point was this: ki suppose I have placed an object over here. I placed an object over here, and I start raising it from this end. So
Then object will fall off.
object will not fall off. The object will be placed over here, and we are raising it slowly from here. Okay, so एक
So slowly,
particular,
slowly only it will fall off.
no, slowly नहीं होगा. एक particular angle पे आके it starts sliding. It starts sliding after reaching one particular angle. By till that angle, it doesn't even slide. It remains at it. Okay. It
Okay.
slides when it reaches a particular angle. Before that angle, it doesn't slide.
Okay. Sir, समझ में आया. I understood.
पक्का ना? Otherwise, I need to show you video.
Okay, show video, sir.
Okay. Did you got my
Yes,
point now?
sir.
है ना?
Yes, sir.
So it's like he raised this particular plank till the time it would start sliding. So at one particular instant, at one particular angle from here, this is the angle. Can you see with horizontal? It will slide
Yes,
down the
sir.
plane. That angle is basically called as the angle of.
Angle of repose.
Is it clear, everyone, guys? Is it clear, guys?
Yes.
Yes, sir.
So
Yes.
it is that angle of inclination of an inclined plane with horizontal at which a block placed on it on the surface just starts sliding. Sir, why are you saying just starts sliding? So that the friction will become equal to, the friction will be equals to what? How much? Limiting friction, right? So at one particular angle of this particular thing, this object will be just slide. That implies the friction acting on it will be limiting friction. Here there will be mg, and here this mg will be broken into two components. If this angle is theta or phi, whatever you want to write the name, theta, so this will be mg cos theta and this will be mg sin theta. Everyone knows this thing, right? We already did this, all this. This is the normal reaction and the block is just about to slide, then all the forces will be just balanced, right? So mg sin theta is just equals to the limiting friction. The limiting friction can be written as mu s multiplied by n. Yes or no, guys? And from here,
Yes.
can you see n will be equals to mg cos theta? So I'll write mg sin theta is approximately equals to mu into mg cos theta. mg will be cancelled out. This cos theta will go downwards. So sin theta upon cos theta will become. So tan theta will be equals to mu s, and even the angle of repose is how much? Tan inverse of. So theta will be equals to tan inverse of. So can you see, guys, it's the same thing as angle of repose, tan inverse of mu s. Are you getting my point?
Yes, sir.
So note for angle of inclination, lesser than the angle of repose, the block will not slide over. Is this clear, guys? So जब तक आपका angle of inclination doesn't become greater than this angle, till the time your angle of inclination doesn't become greater than the angle of repose, till that time the object will be at rest. Okay. Once it becomes greater, then it will slide. Okay. Any doubt in this? Hello, guys. Any doubt in this? Please write it. Please draw the diagram. Tell me to scroll up or down whenever you want. Although there is nothing to scroll, you know, that note which we wrote. That is important, okay? So then guys done. Shall I scroll down?
Yes, sir.
So these were the two angles which I wanted to discuss. Okay. So the theory part of friction is over. Now only the question part is left. So we'll do the question part and today we'll be done with friction. Okay guys? In the next class I'll start with circular motion. Okay guys, did you I told you to decide a day. Which day shall we take the extra classes on? That day of the week. Which shall be that day of the week? Is Thursday fine with you people?
Sir, not Thursday, please. Sir, Tuesday.
Sir, let it. Sir, wait. Which one? Extra classes. Oh, right.
Extra classes for August.
Sir, any day other than the weekend. Thursday, Friday,
Yes,
Saturday.
Thursday, Friday, Saturday, and even Sunday. You just leave those days.
ठीक है फिर we'll keep it on Tuesdays.
Yes, sir. It's
Yes,
fine.
sir.
Yeah, fine.
Because Monday I decided for 12th grade, but Tuesday we'll decide it for you.
Sir, keep it in the morning, sir, so that afternoon we can enjoy a bit.
If
No,
you
but
want,
sir, like keep it after 12.
keep it after
Yeah, that's
12.
fine.
Okay.
Sir,
Like
some
12,
sir,
like
3
12:30 to 12:30 to 2:30, I guess that works.
Yeah,
Yes,
that's fine.
sir, that's fine.
Does that work with everyone?
Yes, sir.
Tanesh,
Yes,
Aman,
sir.
Sanya.
Yes, sir.
ठीक है. So
Yes.
12:30 to 2:30 Tuesday 11th
Okay.
grade, है ना?
Actually, wait. Anyone has extra classes in August? Because if we don't like, you can keep in 10 to 12, sir. That works best.
No need. No morning, sir. We don't
Dude,
wake
it's
up
just
before
one
12.
day. It's
We
just
don't
one
wake.
day per week. One
Okay,
day
if
per
you
week.
have
And only
extra
4
class, then
classes.
fine.
Only 4 classes.
No, I don't have any
That-
class. I'm free on. I'm
For a
completely
whole
free in
month.
August. It's like
Yeah,
Sir,
Monday,
it's like
12:30
4
to 2:30.
classes.
12:30 to
It's just 4 classes for a whole month, and that too 1 class per week. One day you wake up in the morning, it's not harmful. Like 10 to 12, sir, please. Because
Why?
afternoons we keep plans. Bro, afternoon sometimes we make plans, man, to roam around stuff. And then the classes contradict. So yeah, it's better to keep it in the morning. Who roams in the morning over here? 10 to 12 is fine, sir. If no one has any
Who roams
this
it?
one.
Who
extra
roams from
classes.
12:30 to 2:30? It's like
Yeah,
the
in the
most,
hot sun, you get more
huh.
roasted. Where are you going in the afternoon?
Dude, people will go anywhere, man. Mother Emirates or wherever they wish. Sometimes I have to go, sometimes I feel like, what, let's just go, never mind.
Yeah.
I'm just saying, sir, that I make plans in the afternoons and stuff, and then class time contradicts. So if it's in the morning, it's much better.
So don't make any plans or stuff for Tuesday.
It's just a day. You sit from 12:30 to 2. All the other days you go in the afternoon. It's just one day in the week.
Yeah.
Sir, but still,
Chal, ठीक है.
okay.
If everyone
Fine,
is
12:32.
agreeing with 10 to 12, then we'll put it on 12.
So 12:30 to 2. Please. I'm fine with that.
What about others?
No 10 o'clock? Okay, never
No,
mind.
12:30 to 2 is perfect.
12:30
Okay,
to
fine.
2:30 is perfect for 2 people. And so, yes,
Yeah, fine, sir. 12:30. Let's do that.
चलो ठीक है
I guess
वापस
there's not much.
Okay.
Yeah, fine. 12:30 to 2:30.
चलो
When? The when?
in the month of August
Sure.
Every
So which one
Tuesday.
is-
every Tuesday
12:30 to
12:30 to
2:30.
2:30. Okay.
Yes, sir.
Yes, sir.
And does that idea struck in any other faculty's minds?
No, sir.
Right now,
No.
no, na. So please don't let them any hint. If you give them any hint, then automatically you will be in trouble. I will not be in trouble. I am trying my best to hide all these things. So at least you will only have physics, the load for physics in the month of August. And that too I'm doing. I told you the reason already. Last year, it was like we were not having any holidays and all. So that's why. So anyways, guys, chalo, questions, block over block problems. The question is, suppose, can you see one block over another block? Guys, hello? Hello? Guys, are you able to hear me? Hello? Hello, guys, are you able to hear me? Hello? Hello.
Yes, sir.
Yes,
I
sir.
can hear you.
अब बोलो ना भाई मेरे को लग रहा है कि my net gone, it went. So suppose guys, this is let's say 14. Yes sir,
Sir, I can hear you.
can. So guys, this surface, can you say
Can you
this
hear me?
surface? Yes, I can hear. The coefficient of friction is 0 over here, and the coefficient of friction over here is, let's say, 0.4. Okay. Hello guys. The force is
Yes,
not
sir.
written, the force is there. What
Okay.
will be the force between what will be the force applied on the 5 kg block so that the 2 kg block and 5 kg block doesn't have any relative motion between them. So what will be the force applied on the 5 kg? You need to find out this force F so that the 2 kg block and 5 kg block doesn't have any relative motion between them. That is, 2 kg doesn't slide over they both move together. So you need to find out this maximum force F where there is no relative motion between the blocks. Please remember, I told you already, whenever you want no relative motion, you will assume whenever there is no relative motion involved, you will assume this as a common block, right? Yes or no? So you will assume this as a common block of mass, how much? 7 kg, on which you are applying a force F, and this block is moving with an acceleration A. Yes or no? Hello people, are you understanding this particular thing? Huh?
Yes, sir.
We already know what is the common block concept, right? Whenever there is no relative motion between the two objects involved, so you can assume that this is a single block only. Ayana. So we applied a common block concept, and from here we got this equation 7 into 8. Although we don't require it, ultimately when you will solve it, automatically this equation will come. Is it clear? Guys, this is optional. If you don't want this, then it's fine. Now we'll just see the free body diagram of this thing. Now, Control C. This is the first question. That's why I'm doing. So can you see, guys? Now this 2 kg block and 5 kg block, they both are moving. Can anyone tell me what all are the forces acting on the FBD of 2 kg block and FBD of 5 kg block? Yes, with respect to ground, you need to calculate. You don't need to calculate with respect to 5 kg or anything like that. So anyways, FBD of 2 kg. What all forces are acting on 2 kg block? Who will tell me what all forces are acting on 2 kg block? Can you see its weight 2g will be acting down? First thing first, 2g will be acting down. Is it in contact with 5 kg and 2 kg are in contact, right? So 5 kg will be trying to push this 2 kg upwards with a normal reaction N1. So I wrote N1 over here. Yes?
Yeah.
There will be a friction on this block, right? Which the direction of which we will decide a little bit later. Okay? Now similarly, FBD of 5 kg, will it be like 5 kg, 5g downwards? Is this the weight of 5 kg? Yes or no? The normal reaction which 5 kg applied on 2 kg was in the upward direction. So similarly, 2 kg will apply a force N1 on 5 kg in the downward direction. So can you see the N1 which was acting on 2 kg in the upward direction? The same N1 acts on in downward direction because of Newton's third law. Is it clear? Now, can you see it is in contact with the ground? So 5 kg will be subjected to one more force, which is basically N2 upwards. So these are all the forces which are in the vertical direction. Is it clear? Any doubt in this? Guys, are these forces clear which are there in the vertical direction?
Yes,
Yes,
sir.
sir.
Now see over here, guys. The mu over here is given as how much? This is given as 0. That implies this surface is smooth. If this surface is smooth, is there any friction between 5 kg and ground? No friction, right? Yes or no?
Yes, sir.
And but this here they have given certain mu, so there will be friction between 2 kg and 5 kg. Now can you tell me what all forces are acting on 5 kg? 5 kg, there is this force acting on F. So can you see this 5 kg block is having a tendency to move towards right? Yes or no? Can ground apply any friction? No, but will 2 kg apply any friction? Will 2 kg apply any friction?
Yes, sir.
And what will be the
Yes, sir.
direction of that friction?
Sir, left.
So this will be the direction of friction on 5 kg block. The same friction will be acting in the forward direction on the 2 kg. So basically on 5 kg the friction is acting downwards, towards the left, and on 2 kg the friction is acting towards right. Is this clear, guys? This
Yes.
block was accelerating with an acceleration a towards right, and this block is also accelerating with an acceleration a towards right. Sir, why is the acceleration common? Because we don't want 2 kg to move over 7 kg. Is this clear? Is this clear, guys? So we can just make the equations. What will be the equations, sir? Can you see over here? N1 will be equals to 2g and N2 will be equals to N1 plus 5g. So N1 is 2g plus 5g, which is 7g. This equation would have been of any use when this, it would not have been rough. Okay? But here it is smooth, so no need of this equation. N1 is basically equals to 2. Now, can anyone tell me what is the limiting friction between 2 kg and 5 kg? What is the limiting friction's value between 2 kg and 5 kg? Is it mu multiplied by N1? Sir, why are you talking about N1? Because what is the normal reaction between 2 kg and 5 kg? Is it N1 or N2? N1, right? So this will be equals to 0.4 multiplied by 2 into this will be equals to how much? 8 Newton. So basically this is the value of limiting friction between 2 kg and 5. Now guys, I want this 2 kg block to not slide over 5 kg block. So can I say for the 2 kg block to not slide on the 5 kg, the friction acting between them should be less than equal to the limiting friction? Yes or no? When the friction acting between the object is less than limiting friction, then we say what? Then we say what? Hello?
It will not move.
It will not move. So what is the maximum value of friction which is possible? The limiting friction, right? The maximum value is basically limiting value, right?
Yes,
So
sir.
let's calculate the maximum case when friction is max. So basically in place of F you will write what? FL. Are you getting my point, guys? So what was the first equation? Can you see over here? This friction F will be providing you twice of it. Will this be the equation for the 2 kg block? Can you see this equation? This friction is providing the acceleration to it. And here it will be F minus F, which will be equals to capital F minus small f is equals to 5. Sorry. Is this clear, guys? The two equations in the horizontal direction. I think it is clear, right? Equation number 2 and equation number 2 and 3 are clear to everyone. Yes or no? So now I can just write this thing. F minus small f is basically equals to 7a. Yes or no? Hello?
Yes, sir.
First this is the case. F minus f is equals to 5a and f is equals to 2a. But these are the two equations. So can you see when I add both of them, friction is equals to 7a, right? Not friction. You see when I add them, friction and friction will get cancelled and f will be equals to 7. This equation we already wrote. Are you getting my point, guys? So can you see the concept is true? Even after solving everything, we are getting the same equation. So the concept which we applied is true, right? Are yes or no, guys?
Yes, sir.
Okay. Now, this F is basically equals to 2a, and this limiting friction will be how much? 8. So hence 2a max. When I am writing the maximum value of limiting friction, even when I write this as the maximum, even my acceleration will become maximum. Yes or no? Yes or no, guys? And what was the maximum value of limiting friction? Maximum value of static friction, if you remember, we calculated it somewhere, right? So can you see, guys, this is the maximum, so that's why we wrote it over there. So A max is basically the this is the maximum acceleration of the blocks for which they will move together. For acceleration greater than this, the blocks will slide relative to each other. Will slide over each other. Is this clear, guys? Please write. अच्छा अभी मत देखो. When I'll tell you, then write. Okay? इस वाले question में when I'll tell you, then write. Now once you got the acceleration, you can write the force is basically even when अच्छा. Now when you write A as a maximum, then even your force will also become maximum. So can you see this is the maximum force which shall be applied? Can you see 7 multiplied by 4? Maximum force on 5 kg, so that 2 kg doesn't slide over 5 kg. Acha, when you will apply a force greater than 28 Newton, yes or no? What will happen?
Then the object will move.
Then the 2 kg will move over 5 kg and the acceleration of both the objects will be different. So is it clear how to calculate this force? Okay. Is this clear, guys, how to calculate this force? Chalo, please write
Yes.
it. Then we'll come back to the conceptual part again. Did you note till here? Did you
Yes.
note the question? Everyone noted the question? Did everyone noted the free body diagram as well? And the equation?
No, sir, just a second.
Please note it.
Can you scroll up?
Yes, sure.
Done, sir.
Guys, what is the significance of this force? I'll tell you now. Hai? So basically, whenever any block over block problem comes, then you need to find this force first to do any problem first. Okay? So you need to find out this force, then you will be able to understand now what will happen. Okay? Are you done drawing the equations and writing the maximum value of limiting friction and this concept? For 2 kg block to not slide, this should be happening. For this to, the maximum force should be equal to limiting friction. So can you see? I'm trying to relate it with everything. Phase max, this is max, right? Maximum value 832 to A max. Then we calculate A max as this. We put this A max over here to get that max. Yes or no, guys? So basically, this is the maximum force on 5 kg. So that 2 kg doesn't slide over 5 kg. This is the maximum acceleration. And case 1 for external force less than F max. The blocks stick together and move. No. For F equals to F max, the blocks just slides over each other. And case 3, for F greater than F max, the blocks will slide over each other. Okay? Is it clear, guys?
Yes, sir.
Sure. So this was the concept, and now I'm giving you a question based on this. Okay? So, for example, this is 0.3 and this is 0.2. I'm applying a force in this direction over it. This force is this is, let me first, this is 1 kg, this is 3 kg. Guys, just give me 2 minutes, huh? Let me frame the question, please. So in one case, this force is in one case this force is 10 Newton, and in the second case this force is 30 Newton. Okay, so you need to find the acceleration of both the blocks. Yes, guys, I gave you 2, 3 sheets as well. No, have you started working on it?
Yes, sir.
Good. So basically, these two are the cases. First of all, guys, you should always, I told you, no, whenever this is the case, never ever, till the time you are not confident enough, even I am not confident enough what will happen over here. Okay? Hello? Guys, even I am not confident enough what will happen in this case, will this block slide over another or not. So first and foremost, always remember, you should calculate that force for which both moves together. Is this clear? So what is that force? You calculate. So let's say this is your 1 kg block. This is your the 3 kg block. First thing first, you'll do what? You'll find out what? The limiting friction between them. Yes or no, guys? Will you be able to find the limiting friction for both the objects, for both the surfaces? Yes or no, guys? Will you be able to find
Yes,
out
sir.
the limiting fraction? Shall I teach you again how it's fine? This 3 kg will be
Limiting friction is going to be 3 kg into 0.3 into 9.8. What?
why did I write 4 over here?
Plus 3 plus 1 the total mass of the
The
body.
total mass, exactly. So basically this ground will be feeling what? The weight of both the objects, whereas 3 kg will be feeling the weight of only 1 kg. So that's why the normal reaction is only because of this. Is this clear? So can you see over here 1 is because of this and 4 is because 1 plus 3. Are you getting my point, guys? Direct trick है, लिख लेना. So once you are done with the limiting frictions, after this, what will you do? You'll draw the forces. Anji, 3 kg. Is 3 kg trying to move in this direction? And please remember, you need to find the force for which both the object moves together with the same acceleration. When there will be same acceleration, what will happen? There will be no relative motion. So 3 kg and this is the value f. Now, when this 3 kg is trying to move towards left with respect to 1 kg and with respect to ground, with respect to 1 kg and with respect to ground, can you tell me what will be the direction of friction due to this and this and this on this? Friction due to 1 kg and ground on 3 kg. Will this be the direction of friction from the ground? Yes or no?
Yes, sir. The limiting friction, right?
Not Abhi, will come to the limiting friction later. Will this be the friction? Yes, it will.
Yep.
So this will be the friction from 1
Why do you
kg
multiply
on
0.2?
what?
This is 0.2 into 4 into 10. Why do you multiply 0.2?
Because it was 0.2, no? This was 0.2.
So, oh, yeah, fine, got it, sir.
So even F1 will be acting, F ground will be acting, and even F block will be acting in the backward direction, right? And let's say the object accelerates in this direction with an acceleration. Okay. The same thing, even our 1 kg block. So this, can you see this friction acting on friction due to 1 kg? So this will
Yes,
be
sir.
the same friction. इसको 1 friction due to 3 kg is basically, or in spite of naming it like this, I can just name it as F1 and F2. Is it fine? Because you people will get confused what will happen. So F1, F2, and here also it will be. Is this clear, guys? Everyone, is it clear? Is it clear, guys? Can you
Yes,
see
sir.
F1 is basically the frictional force between ground and 3 kg, and F2 is the frictional force between 1 kg and 3 kg block. So can you see, since this external force was trying to pull this 3 kg towards left, so that's why 1 kg and ground both were opposing together, and this will be the direction of friction. Yes. After this, what happens? The same friction happens on 1 kg as well. So the same friction acts on 1 kg, and that is basically 2 kg. So F2, and if this object accelerates towards with an acceleration. Now we told this though, for these block for 1 kg to be at rest, for 1 kg to be at for 1 kg to be at rest over 3 kg, the friction F2 should be less than what is the limiting friction between 1 kg and 3 kg. Yes, tell me what is this F2 should be less than 3 Newton. Is this clear, guys? F2 should be less than 3 newtons. Yes or no? Ayana, guys. Hello? Is it clear? Can you see the force between 1 kg and 3 kg was F2? And for 1 kg to be rest over 3 kg, this frictional force F2 should be less than the limiting friction. Yes? Can you see F2 is less than the limiting friction? Ayana? Hello? Nobody is saying anything. Are you understanding?
Yes, sir.
Did you
Yes,
understand
sir.
the direction F2, F1 on 3 kg block? Everyone was understanding the direction, right? Did you understood the direction of F2 on 1 kg? Anyone having any doubt in that? Why is the direction in the opposite direction? Because for every action there is equal and third law. So if friction on 3 kg acting towards left, then friction on 1 kg will be acting towards right. Yes? Now if I don't want any motion between 1 kg and 3 kg, then this friction, which is F2, it should be less than 3 newtons. Where what was 3 newton? 3 newton was the limiting friction between 1 kg and 3 kg. Yes or no? Any doubt till here, guys?
No, sir.
So from here, can I say the maximum value of F2 will be equals to how much? The maximum case will be how much? 3 newton? Yes or no? Yes or no? And can you see F2 will be equals to 1 into A. So if I make this as the maximum, F2 will also become maximum. Yes or no? So 3 is equals to 1 multiplied by A max. So from here, maximum acceleration comes to be 3 meter per second square. Yes? Yes or no, guys? The acceleration maximum is equal to 3 meter per second square from this FBD of 1 kg. And from here, we'll go the FBD of 3 kg. What is the FBD of 3 kg says? F minus F2 minus F1 should be equals to 3 into A. Yes or no? Yes or no, guys? Now tell me this particular thing. When A is the maximum, F2 is the maximum. If this F1 also becomes maximum, will this F will become maximum? Are you getting my point, guys? These two are given. These two are given according to this condition. If F1 becomes the max, then even F will become max. So this is the logic we applied. If we make this F1 as maximum, then this F will be the maximum, ultimate F, right? Ultimate capital F which we want. So what was the maximum value of F1? Can anyone tell me what is the maximum value of F1? What is the maximum value of friction on 3 kg in ground? Was it 8 Newton? Was it 8 Newton, guys? Yes or no? Was it 8 Newton? So this will be F minus F2 plus F3 max. So F will be equals to price of A max will be 3 meter per second square, and then this will come over here, it will become plus F2 maximum was 3 Newton and F1 maximum is 8 Newton. So ultimately 9 plus 11 Newton. And can you see from here the maximum force which will be applied so that both the blocks move together is 20 Newton. So can you see, guys, what will happen when you will apply 10 Newton? Sir, what was this all this fuss about? Our question was not even this, but now with the help of this thing which you do, these two questions will be solved very easily. Now you know the force due to which these two blocks are moving together. So now when the external force is 10 Newton, and I think 10 Newton is lesser than 20 Newton. Yes. So both these blocks will be moving together with the same acceleration A with no relative motion in between. Yes or no, guys? Yes or no, guys?
Yes, sir.
So basically, what will be the force on these two blocks? So the force was how much? 10 newtons. There is no relative motion between the blocks. And now can you see? This thing will move as a common block over. Okay? This will move over with a common acceleration A. But can you see now what will be the limiting friction on this? What was the value of limiting friction acting on this? Was it 8 Newton? It was 8 Newton, right? Guys, the limiting friction acting on the lower block, was it 8 Newton? This was the friction, right? The maximum. Are yes or no? So this was 8 Newton, this is 10 Newton, and this whole thing will be supposed to be how much mass? 1 kg plus 3 kg. The total mass will be 4 kg. So I can write capital F minus FL will be equals to 4 multiplied by the A in this case, and this will be 10 minus 8. From here A is equals to 0.5. So can you see over here, both the objects will accelerate with the acceleration of 0.5 meter per second square. Is this the maximum possible acceleration? No, the maximum possible acceleration was this, where both the objects were moving together. So is the first part clear of the question now, how to do it? Guys, can you see with the when we were calculating this 20 Newton force, we now know what will happen. Exactly my point. Yes or no? Hello? Are you able to get my point?
Yes, sir.
So this is why we calculated that 20 Newton force. So that we can relate it with whatever force which is given. Now, what is the second case when the force is how much? 30 Newton. Now, when the force is 30 Newton, what will happen? Now the blocks will slide over another, right? Will the blocks slide over each other? Will the blocks slide over each other? Since the applied force is greater than the maximum force, now the blocks will slide relative to each other. So when they will slide relative to each other, what will happen? Guys, what will happen when they will slide relative to each other? The accelerations will be different. Yes? Will the acceleration be different? So let's say this acceleration is A1 and this acceleration is A. Is this clear, guys? So when the blocks will slide relative to each other, then their accelerations will be different. Acha, remember, yes, A1 and A2, A1 and A2 are with respect to ground. Okay? Please remember, A1 and A2 are with respect to ground. Is it clear, guys? Everything is happening in the ground field. Now, what will be the direction of frictions? This will be the direction of F1, this will be the direction of F2, and this will be the direction of F2. When this force was 30 Newton, can I write this particular thing? 30 Newton minus F2 minus F1, or F2 plus F1 is basically equals to 30. 3a. Can you see, guys? This is the first equation. I told you now the acceleration of both the blocks are different now. So 3a2. Yes. Hello.
Yes, sir.
Yes,
This
sir.
is the force on 3 kg. The force equation on 3
So
kg.
30 V, right?
30 N, 30 Newton.
N. Yeah. Right.
So 30 Newton minus F2 and minus F1, or basically minus F2 plus F1 is basically 3A2. The second force will be
Plus F2 also, right?
minus F2 bracket में F2 plus F1. You see, both were opposing, only this was driving. Similarly, F2 over here
ये
will be
चैप्टर
equals
तो खत्म हो रहा है.
ये हो गया, ये इस क्वेश्चन के साथ में हो गया.
Yes.
Chapter is over, but I am just giving you certain questions so that you will be able to relate how limiting friction will be changing the lives. Okay.
So by the way, did we do physical world?
We did no units and dimensions. We did, and
Oh.
most of it was the definition. The SI units were having certain definitions and all.
Yes, sir. Done, sir.
So almost, we did that, by breaking it into various pieces. We did SI systems. We learned about SI systems. We learned about some units. What are units? What are measurements? Right.
Yes,
We
sir.
didn't give a name to that chapter, but we just broke that chapter wherever it was required. See, one part of that we studied in force.
Yes, sir.
If you remember, I told you, that the force can be divided into physical, the four different forces categories: gravitational, electromagnetic, strong nuclear, weak, right? So that was a part of the first chapter, but we broke it, and we broke that first chapter, and we study it wherever it is used. So, anyways, now guys, F2 is providing the A1, right? Yes or no? Now, since the blocks are now in relative motion with each other, the friction is not static anymore. Yes or no? If the friction is not static anymore, then we'll use the kinetic friction. And please remember, if kinetic friction is not mentioned, then you'll take the kinetic friction as your limiting friction. Is this clear? So basically, this will become limiting value. This will and this will all will become limiting value. So whenever there is a relative motion of the blocks over blocks, then this happens. Is this clear, guys? Friction is not static anymore; it will become kinetic on both the surfaces. So F2, what was the maximum value of F2, guys? What is the maximum value of F2? 3 Newton, right? Yes or no?
Yes, sir.
So 3 Newton is equals to 1 into A1, and can you see the acceleration of the 1 kg block is how much? Acceleration, I told you, na, see? Hello. The 3 kg acceleration is A2, and the acceleration of 1 kg is A1. So can you see from here, A1 is basically equals to 3 meter per second. So can you see this was the maximum possible for A1, right? Do you remember this? In simple words, what was accelerating this 1 kg blocks? Was F2 accelerating 1 kg block? Yes or no? And when we calculated this maximum force, this 1 kg was accelerated by the maximum value of friction. So that's why we got the maximum value of acceleration. And can you see the A1 is not able to go beyond this thing, beyond 3 meter per second, right? So this is the maximum possible acceleration of 1 kg. But what about that other block? The other block will be F minus F2 minus F1. No? So F minus F2 minus F1 is equals to P into A1. So I'll put the limiting values. This will be the 30 Newton. This limiting value is basically 3. This limiting value is basically 8, and this is equals to thrice of even. So 30 minus 11 is 19 by 3, and this is 3. So can you see the acceleration of the first is 19 by 3? Can you see so A2 will be equals to 6.33 meter per second square. So when you raised the force, when you raised the cap force, driving force, can you see the acceleration of which block increased? Which block increased? The acceleration of the second block increased, but the acceleration on where you were not applying any force, it remained the max. This increased. You getting my point, guys?
Yes, sir.
So don't know. Shall I go to the top again? Guys, please start writing. Till where have you finished? Did you finish till here, where we calculated the maximum force? Guys, hello? Hello, hello.
Yes, sir.
Did you finish till here, where we calculated the maximum force?
Yes, sir.
Then do this when F is equals to 10 Newton, what will happen? And when F is equals to 30 Newton, then what will happen? And then I'll give you some questions of our homework. Chalo, likho. And then give me 2 minutes. I'll just flash now. Hello guys, done? The first case, did you write the first case?
Yes, sir.
Now please write the second case. All these are different questions, but I am trying to club it for you so that at least you will be able to relate between questions, right? They will not be able to. They will not be giving you anytime like 2-3 questions together. They will just give you this is 30 Newton force. Tell me what will happen. So first you should get an idea that yes, whether there is a relative motion between the blocks or not. If there is not, then we do this. Okay. Is this clear, guys?
Yes, sir.
I'll give you one more question, and as a homework, and then we'll do some more questions on this, and then that's it. Some more questions on friction we'll do, and we'll finish off with the chapter today. Because the conceptual part is over, only the solving part is there. Okay? Carol, write it, please. Please write it. Guys, is it clear? The box over box problem clear? Guys, is it clear? The box over box problem?
Yes, sir.
Chalo. I'll give you some questions as a homework. So please try them, guys. है ना? ऐसा मत करना कि sir, I'm not trying them. ऐसा कुछ. Please try them. Question में, there are 3 blocks which are placed over each other, not over each other, placed one by one, and they are placed on a smooth horizontal ground. Despite of drawing this, let me draw it using the tools. So basically, this is one block. Control C, Control V, थोड़ा सा बड़ा block and लंबा block. So this is the second block. And Control C, Control V. So guys, can you see 3 blocks? And then there is a line. This is the line. Guys, the friction between these two surfaces is 0.2. The friction between these two surfaces is 0.3, and the friction between these two surfaces is 0.0. That means this is smooth. Is it clear, guys? Hello, is it clear?
Yes, sir.
So this is A, this is B, this is C. The mass of A is given 2 kg. Basically, the 2 kg block. A is basically a 2 kg block. B is a 3 kg block. And C is basically a 7 kg block. Now the question is, if a horizontal force, if A1, A2 and A3, if A1, A2 and A3 are accelerations of 2 kg and 3 kg and 7 kg respectively. Basically, A1, A2, A3 is A1 to yes or yes. Is this clear? Is this clear, guys?
Yes, sir. Yes, sir.
If A1, A2 and A3 are acceleration of 2 kg, 3 kg and 7 kg respectively, find A1, A2 and A3.
सर आज जल्दी ब्रेक मिल जाता मजा आ जाता.
भाई मजा तो हटे, हर बार ही आता है.
सर आप मजा देते नहीं हो सर. सब मैथ सर आल्सो गिव अर्ली ब्रेक टुडे.
तो मैथ सर ने दे दिया तो फिर मेरी क्या सर, यू नो व्हाट द नीड ऑफ मी?
No, मैथ सर डिडंट गिव. दैट्स व्हाट आई मेंट टू से सर. मैं मुंह से चिपक गया.
मैथ सर की तो क्लास हो चुकी होगी ना अभी तक. A1, A2 and A3.
सर प्लीज सर अर्ली ब्रेक सर.
ठीक. So basically,
7:45.
let me give the questions at least. We'll do some questions. I need only some questions are there. I'll give you some.
7:45.
भाई मैं तेरे को होमवर्क दे दूं कुछ क्वेश्चंस. वो वाले क्वेश्चंस देने के बाद 1-2 क्वेश्चंस I'll do and then I'll leave you early.
ठीक है सर.
A force of 10 Newton is applied on. So basically this question has how many cases? 3 different cases.
Oh, ये था.
So basically in one case you will apply a force F on this A block. In the second case you will apply a force A on the B block, and in the third case you will apply force 10 Newton. In every case the force is basically 10 Newton on the C block. and tell exactly what will happen. This problem is from H.C. Verma, friction chapter. So try to do those. I'm telling you the source as well, because even if you know the source and the solution, it will be like, "Hey, sir, please samjhao." So, anyways, next question. There is a block A, there is a block B.
ये solve करूँ मैं?
No, solve it later. It's a homework question.
Okay.
So, guys, can you see two blocks? These two blocks are placed on a rough, on a smooth horizontal surface. Okay, guys. So basically, they are placed on a smooth horizontal surface, and can you see a string over here? Okay, this is capital M. This is 5. No? This block is 5 kg. This block is 20 kg. Now the question is, find the mass capital M for which the block A will just start sliding over B. Please remember, if block A is just sliding over B, then this block is A and this block is B. The block A will be just sliding over block B. Is this clear? So basically the friction will be limiting, okay? Is this clear, guys? So this is one of the questions. You need to find out what will be the value of this capital M. What will be the value of this mass M? Is this clear? Next question. This question we did already. And this question also we did. Last question which we will do today. What's the time? What's the time? 7:30, no? Take it 15 minutes early, I can leave you. But I need to do one question, okay? Only one question I need to do, and the friction chapter.
सर मैं आपका शुक्रियागुजार हूँ.
कोई बात नहीं. वो वाले टाइम में you can solve those questions. एक और I'll give you one more homework question. What? Anjay, can you see two blocks? Hello?
Yes, sir.
There is a force F1 equals to 20 Newton applied on this block, and there is a force of F2 applied of 5 Newton on the upper block. Okay? Hello? Is this clear, guys? There are two forces applied now. This is a 1 kg block, and this is a 4 kg block. Okay? So basically these are your two blocks. The surface on which they are placed is smooth, and this is equals to 0.1. Now let's make it 0.2. Okay. So the friction between 1 kg and the coefficient of static friction between 1 kg and 4 kg is 0.5. Find the accelerations of both the blocks. So this question again, free body diagram, you need to assume the direction of friction and all. But obviously, whatever be the direction of friction on 1 kg, that the opposite will be acting on 4 kg, right? ये तो सबको पता है, इतना तो है ना? है ना?
Yes, sir.
Okay.
Yes, sir.
एक सेकंड. 10, 8 and 4 kg. थोड़ा सा. This force is 30 Newton, okay? Okay guys, F1 is 30 Newton, and then try to do it. So these questions are your homework question, block over block problems. Only one last question we will do in class. That is, suppose, no, one last thing. There will be two questions. This block is of mass 3m, and there is this block of mass m, which is not fixed over this block. This block can slide, okay? But what was happening, basically, I am pushing this 3m block with a force F. With a force F. So the question is, in the situation shown in the figure, a block of mass small m is supported on the front surface of a bigger block of mass 3m. Okay, it is supported, it is not fixed. Okay. Now the coefficient of friction between small m and 3m is mu. Question is, find the minimum force required to find the minimum force F required to apply so that small m will be at rest with respect to, it's not block over block, it's just block in two block systems. So that's why this doesn't fall in the category of block over block problem. So that's why this question has to be discussed in the class. How will we do any question in mechanics? We'll draw with free body diagram. हमेशा यही करते हैं ना? We start with drawing the free body diagram, right or no? For any problem in mechanics, we start with drawing the free body. So start, draw 3m, draw m. If you want, you can use the concept of pseudo force. If you don't want to use pseudo force, you can use normal concept. No worries. Is it clear? Shall I give you time to solve this? After this, there is one more question, है ना? The inclined plane one. Okay, the next class will be starting with circular motion. We'll start with the kinematics of circular motion, and then we'll do the mechanics part. But by the end of this week, We'll be done with your circular motion as well. And in the chutti wala times, we'll start with work, fire, energy, and rotation. Okay? Is it clear, guys?
Yes.
So how will we do this question, guys? First of all, we'll draw the free body diagram. So FBD of 3M. It is placed on a smooth horizontal floor, so no friction between 3M and this. Now tell me this particular thing. If M is not sliding over 3M, that implies they are sticking to each other and they hence will be moving with a common acceleration of how much? A, right? So I can say this particular thing F is equals to 4M into A. Yes or no, guys? Hello? Can I say this?
Yes, sir.
As a common block concept, right? If you remember common block concept according, I can say this, but I will not say this. So FBD of 3M, if I will draw, so can you see this F acting towards right? So F acting towards right. Is there any friction acting on from the ground between 3M and M? 3M and ground? Is there any friction here? Here is there any friction? No, so we'll not write it. Now what is the normal reaction due to the ground on this 3M? Let's name it as N2. And now this M will be pushing this 3M in this direction. Let's name it as N1. So N1. And mg is also there. See, this block has a tendency to fall, right? M is having a tendency to fall over 3M, right? Yes or no, guys? I am not drawing the direction of friction as of now. First, let's see what is the direction of friction. For that, let's go to M, FBD of M. Now for M, mg will be acting downwards. So can you see mg? Let me draw it a bit. So we have drawn N2. We drew N1. We drew 3mg. We drew this F as well. So basically we drew all the forces except the friction acting on this 3M. For that we are doing this. So mg is acting downwards. The normal reaction N1 which we drew over here, that N1 will be acting like this. So N1 will be acting in this direction. What else? Anything else apart from this? No, nothing, right? There is a friction acting on this and this object is accelerating towards right. Yes or no, with an acceleration in A, and this also is accelerating at A. Now tell me this particular thing. We understood this particular part ki N1 is providing the acceleration for it to move towards right. But what about friction? What about this mg? Does this mg is balanced with anything? Is this mg is balanced with anything? No, right? As of now, no. So what we will do? This object was not falling down or going up, so there should be a force for which this object will not follow, right? So this object, since it has a tendency to fall towards down with respect to this object, hence this 3M will apply a force in this direction on this model, and this will be the friction. The same friction will be acting in the downward direction for this model. Is this clear? So this is your free body diagram. Now this block, can you see? It is just having this acceleration. So I can write N1 equals to N. and I can write this f should be equals to mg. Similarly, n1 and f, so f minus n1 is equals to price of m into a, and n2 I don't require as of now. I still write the equation. The n2 should be equals to 3mg plus f. Okay. Now, guys, for m to not slide over, or basically, what was the question? How they will divide over 3m. This friction should be less than the limiting friction, right? Yes or no, guys? Hello? Yes or no, guys?
Yes, sir.
So, is this clear? F is less than Fl?
So
Less
if
than
FL
equal
is
to
greater
Fl?
than,
F is less than equal, less than equal to the limiting
then
friction
not sliding.
and not sliding. It is at rest, no? So basically, if I say this will be max, then this will be the maximum case, right? Are Hayana, can you give me the equation? Where
Sir.
was this N1? So F is equals to mg.
Doing it.
If I do this as maximum, now you can solve it directly, no? Here we don't require all that logic, no? So can you see over here? F should be equals to Fn. Just simple एक वो कर दो. For the maximum case, for the limiting case. For the limiting case, the friction should be equals to limiting friction. So basically this friction should be equals to limiting friction. So now mu times of n1 should be equals to what? Can you see? Hello people. Hello, hello. So this F was equal to mg according to this equation, and the limiting friction was equals to mu into n1 from this equation. So since you made this as max, so even your n1 is max. Yes or no? Since FL is basically the maximum value, so that implies n1 is also having the maximum value. Yes or no? Yes or no, guys?
Yes, sir.
N1 is having maximum value, and this will n1 will be equals to what? mg divided by, yeah, n1 will be equals to mg divided by mu, and this will be the maximum value. Sir, why do you require the maximum value? Because from here I'll do this. So can you see over here, n1 is equals to ma. So n1 is equals to ma. If I make this as maximum, this will automatically become maximum. So this will be equals to how much? This will be equals to how much? mg by mu should be equals to m into a max, and a max will be equals to g by. Is this clear? Is this clear, guys? Is this clear, guys? This is the maximum acceleration with which this will move. Now, once you got the value of a max, you'll put it over here. And now, see over here, guys. This is the equation. The third equation is like this. Max. We want the n1 was equals to how much, guys? You remember these two equations which we did in the beginning of the question, f minus n1 and n1 equals to n1. From these two equations, can I write F is equals to 4 times of Ma? Yes. So if A is maximum, then your F. So F max is equals to 4 times of Ma. So can you see, guys, the maximum force is basically how much? 4 mg by min. Is it clear? Is this clear?
Yes,
Yes,
sir.
sir.
This was the question. And we are done with this. We're done with friction. In the next class, we'll do circular motion. Are you done, guys? So let's scroll down.
Yes, sir.
This clear, guys? Sure. We'll see you again in the next class. I hope you're done writing, right?
Yes, sir.
Hello. Sure. We'll see you again in the next class, guys. Thank you very much. Tanish already left. Huh? तनिष ऑलरेडी लेफ्ट राइट पता नहीं क्या इसके एक बार घर पे कंप्लेंट करनी पड़ेगी चलो
So he left just now. Yes,
let's
sir.
just
Yeah.
चलो ठीक है we'll see you again guys चलो bye bye thank you very much